we will be investigating applications of a system of linear equations, specifically steps to solving applied problems, and looking at two specific types of problems, geometry problems and money problems. First, let's talk about steps. Step one is always to read the problem, and we're going to take specific note of what is given and what we need to find. Step two will be to assign variables, and because we're working in a system of linear equations, we will often have two variables that we want to solve for. Step three will be to write that system of equations using those variables, and four will be to solve the system of equations. Often, we will be using the idea of substitution. Step 5 is to make sure to state the answer to the problem, including labeling correctly, whether we're looking at feet or dollars or ounces. Make sure to label. And step 6, like always, is to check our answer. I can use the idea of substitution in solving this money problem. For a high school football game, 2 adult tickets and 1 child's ticket cost $10.50. If 1 child's ticket costs $2.50, how much does 1 adult ticket cost? First, I'm going to set up my 2 unknown variables. I'm going to say that A equals the cost of an adult ticket in dollars, and that C equals the cost of a child's ticket in dollars. Now I want to set up my system of equations. First, I see that 2 times the cost of the adult ticket plus the cost of 1 child's ticket added together equals a total of $10.50. Next, I recognize that the cost of a child's ticket is $2.50. I'm going to use this cost and this variable C equals $2.50 and plug it in to my first equation. Doing so, through substitution, I find that 2A plus $2.50 equals our total of $10.50. Next, I'm going to subtract $2.50 from both sides to see that 2A equals $8. Then I'm going to divide by 2 to see that A equals $4. So since A represents the cost of an adult ticket, we know that this solution shows that 1 adult ticket is $4. Let's look at a geometry problem. A rectangular basketball court has a width between 50 and 100 feet, and the length is between 100 and 130 feet. This particular basketball court has a perimeter of 320 feet. And we're going to want to remember that perimeter means to add up all of the outside edges. If the length measures 40 feet more than the width, what are the dimensions of the court? Well, we have read the problem, and now we're going to use our variables of L equaling the length and W equaling the width to help solve this problem. Our third step is to write a system of equations. We know that our perimeter is 320 feet, and the perimeter of a rectangle says add up all the sides, so I'm going to be adding 2 lengths plus 2 widths to total to 320 feet. Next, I was told that the length is 40 feet more than the width, so I've written that the length equals the width plus 40. Now, I have 2 equations with 2 unknown variables. So I'm going to solve this system of equations using substitution. I know that my length equals my width plus 40, so I'm going to take and plug that into my first equation. My new equation then is twice the length, which I'm going to rewrite as W plus 40, plus 2W equals 320. This is my first equation rewritten with substituting in my second equation. Next, I'm going to distribute 2W plus 80 plus 2w equals 320. I'm going to combine like terms. 4w plus 80 equals 320. And subtract 80. 4w equals 240. And when I divide by 4 on both sides, I find that w equals 60, or my width equals 60. Since I have found that w equals 60, I'm going to plug that into one of my two equations to find the length. And it's easy to plug into my second equation because I've already solved for L equals. L equals w plus 40, 60 plus 40, or 100 feet. So the length is 100 feet and the width is 60 feet. Note that I labeled both answers. And as always, I want to double check that this is true, so I have plugged in my length and my width into my perimeter formula and found a true statement.